Okay, we have another type of distribution here, and it's called a Poisson distribution. And we have formulas in the upper right that I wrote in green, and these type of random variables typically follow this pattern. And something to point out, so let's look at an example for the second one is this lambda here, lambda equals 10. That's a parameter. We could think of that almost as a mean. So the number of fire insurance claims, is Poisson distributed with lambda 10. And notice over here, right, expected value is lambda. So kind of like the average each month. Yeah, each month is 10. Now, one thing to point out with Poisson is there really is no bounds, right? Like other distributions we've been looking at, many of them had a cutoff, like x had to be between 0 and 10, let's say. All right, it's not likely, right? But this company could have, many, many, many insurance claims, like thousands, right? I mean, the whole town burned down. Kind of over exaggerating, but still. And remember with the probability that the sum of all the probabilities have to equal 1. So in that case, if it follows this Poisson distribution, it can be shown that when we add all these probabilities all the way to infinity, it takes a special sum, which we're not going to look at, we would in fact get 1. Okay. So quick little background. Now most problems will just tell you, it's Poisson distributed, and here as well, Poisson distribution. So first example, how does this look? So suppose a random variable x has a Poisson distribution with lambda equals 3. We want P6, P7, P8. So P sub 6. Using the formula, it tells us do lambda to the 6, and lambda is 3 in this case, so 3 to the 6 over n, so 6 factorial, multiplied by e to the negative lambda, which is 3. Right? Lambda is 3, n was 6 for this example. Your calculator should have this factorial function. If you can't find it, remember a factorial just means 6 times 5 times 4 times 3 times 2 times 1. So whatever number it is, multiply all the numbers below it all the way down. Well, you don't need 1, but all the way down to 1. All right. So this yields 3 to the 6 is 729 over 6 factorial is 720 times e to the negative 3. No matter what, you're going to need a calculator. So we get approximately a 0.0504. Okay. P7 is done the same way as is P8. One thing I do just want to point out though, P7 would have 3 to the 7th over 7 factorial, e to the negative 3. So what I want to point out is notice if we just took P6, right? If I took P6, which is 3 to the 6, then what am I missing? I'm really just missing a 3, right? Because I have 3 to the 7th. And then instead of 7 factorial, I had a 6 factorial, so all I'm missing is a 7. So I could take the result from above and multiply it by 3 over 7. We get approximately 0.0216. I mean, regardless, you're going to need a calculator, so what's the difference of taking that result and times in 3/7 or just redoing it, right? And similarly, P8 would have another 3 and we'd have an 8. I'm just going to tell what the result is. We get 0.0081. So notice as well, as we get larger, these values, 0.05, 0.02 approximately, 0.008, right, they're getting smaller and smaller. So if we summed all of these numbers, the P sub, all the way to infinity, we would get 1 because these are getting infinitely small. Okay. Next example with this insurance claim. So what is probability that in a given month no claims are filed? So written out in probability, we would say probability that x equals 0 since x is the number of insurance claims. Okay, x is the number of insurance claims. All right, well, for A then, P of x equals 0, that's P naught, right, equals, P naught is e to the negative lambda. So e to the negative 10, because 10 is our lambda that's given. We get about point, very, very small chance. It's 4 zeros, 454. Let me go ahead and separate this here. All right, there's first example. There's our second. Okay, so there's A. B. What is probability in a given month? No more than 2. Okay, no more than 2 would mean we could have 0, but we could also have 1, or we could have 2, right? Probability x is less than or equal to 2. So that's equivalent to saying the probability of nothing plus probability of 1 plus probability of 2. Okay, this one we just did, right? That's from part A. So P1, let's do that one really quick. P1, we have lambda to the 1, so 10 to the 1 power over 1 factorial. 1 factorial is just 1. 1 multiplied all the numbers down to 1 is just 1, right? Times e to the negative lambda, which is 10. So again, could use the calculator. I'm going to show really quick how we could, I don't know, somewhat simplify. In the end, we're going to need a calculator anyways, but P naught was e to the negative 10, right? Notice this also has an e to the negative 10. So we'll end up, use right here, just to separate, we'll end up factoring out at e to the negative 10, and it's not too bad, but then e to the negative 10, we need a calculator. Okay, P2. So that is lambda 10 to the 2 over 2 factorial, which is just 2 times 1, so just a 2, e to the negative 10. So again, e to the negative 10, right? So what I'm saying is factor that out, and we're left with a 1 plus 10 over 1 plus 100 over 2, right, 50. So 61 e to the negative 10, and plug that in the calculator, get about 0.00276994. Now remember, the mean was 10, right? These guys have a lot of insurance claims. Probably charging a huge premium, but anyways, if the mean is 10, it makes sense that the probability x less than or equal to 2 is quite small, right? Not even 1%, 0.02, so 0.2%. Okay, and C, the last one, find the probability in a given month that at least 3 claims are filed. Well, this here is less than or equal to 2. So if I want at least 3, then that's just the probability, I'm going to just do it over here, that x is greater or equal to 3, right? Well, that, if this or this happen, that would be 100%, right? That'd be all the claims. So therefore I could just take the result I got from B and subtract it, subtract that result. So if I do 1 minus the 0.002, we get 0.99 approximately, because we did round. 0.9972306, depending where we want to round. 99.7%, right? Probability at least 3 is almost a guarantee. One more example. Okay, so they're making cookies for a batch of 4,800 oatmeal and raisin cookies. So there's 4,800 cookies. How many raisins should be used so that the probability of a cookie having no raisins is 0.01? All right. And then it tells us it's Poisson. So let's go and separate this. All right, so the probability of having no raisins, that tells me then X has to stand for the number of raisins in a cookie. Because I want the probability that X is no raisins, right? X equals 0 is 0.01. So then we want to know like how many total raisins should they use. I guess let's go ahead and use R as the variable. We'll say R is the total number of raisins, like for this entire batch of 4,800 cookies. Okay. This one took me a bit to kind of work out. But here's the idea. The mean, let's switch colors here. The mean is this number of raisins, right? I'm going to use like, let's say 1,000,000 raisins, and I'm going to split it up to those 4,800 cookies, right? So on average, I would have however many raisins I use divided by 4,800 cookies. Now, I don't know what that is because I don't know the number of raisins, but that's lambda, right? That's my average. It's my expected value. Of course, not every cookie will get the same exact number unless someone's sitting there, putting a raisin, however many raisins in each one. All right, so this is what we needed, and that was kind of the weird part. It's not exactly given in the problem, right? So probability of X is 0 is P of 0. And P of 0 we know is e to the negative lambda. But lambda we said is this r over 4,800. So e to the negative r over 4,800. Okay. So I'm gonna rewrite that one step down. P naught equals e to the negative r over 4,800 because now we need to solve it by, we're solving for r, right? I want to know the total number of raisins. So we need natural log of both sides. Oops, and my bad, I meant to do this. We also know P naught is equal to 0.01, right? That was given. We want that to be 0.01. So I'm going to change that in there. Otherwise, I have two variables and I can't do anything. So ln and e cancel. I have ln of 0.01 equals negative r over 4,800. So multiply both sides by 4,800, or let's go and do the negative as well. And r, you're going to need a calculator, right? Negative 4,800 times ln of 0.01 is about 22,105. So what does that mean? You should use 22,105 raisins for a batch of 4,800 so that the likelihood of getting no raisins is that small, right? 0.01. Whoops, 22,105 raisins should be used.